Hey, now we talk about a very technical term. It's called CEP or circular error probability. What is this? Okay, this is now a very technical term. It has to do something with weapons. And it's something like a radius defined in meters or kilometers. Yeah? So really it's like distance. And it's the radius you're going to, it's like a circular target, you're trying to hit my nose, and you are hitting with a 50% chance in this radius. That means like if you you are shooting on my nose, and now you're shooting, and you would be hitting always 50% of the shots would be hitting inside of my face. So the circular error probability is like this distance, So it's like the radius actually from here to here. But, that's like how far off are your shots? And 50% will be outside of my face. Yeah? So that's like basically saying what is circular error probability. So, and nowadays we have weapons which have a really very small, they are very precise. You can even like in the Iraq wars, you saw images or videos of aircraft dropping laser-guided bombs so precise that they were like going into ventilation shafts or windows. So you could really see, okay, that thing is going there. If you have seen like Maverick, the Top Gun, the second one, they're like sending a weapon down really precisely in this kind of shaft there to destroy the whole underground facility. And that's actually possible. It's there. These weapons are like, there's a laser, it points and to that point, and then this weapon is automatically guiding itself into this thing. So you can make a weapon today very precise. And laser guidance is one thing. You have to be there to lace the target. But there are other options as well. There's like GPS guided bombs, but you can jam the GPS. But then there's again, you can use other things like a cruise missile is doing. You can see and scan the terrain. You can even use images. You can use an image and then actually lock on that thing. So there's all kinds of stuff what military technology is doing. But why are we talking about this? Well, I just want to come over that today you can really deliver something really pretty precise. You probably have seen some videos of the Ukraine war where the drone is delivering such a small warhead, which is like only several kilograms of destructive power. And it's just delivering it onto a tank, and then the whole tank blows up. Because this weapon is really precisely aiming to where the sweet spot is on the tank, usually between there in the rear or at the turret ring. And you deliver it really precisely what an operator is steering, and then poof, the whole tank explodes. What has it to do with nuclear weapons? Well, in the 1940s and 1950s, the technology wasn't that advanced. You were trying to bomb something and destroy it. That was like terribly imprecise. They used like hundreds or thousands of planes filled with bombs to bomb certain areas. Yeah? Because you were throwing a bomb from like several thousand meters up in a bomber. You were throwing it and you had like a mechanical bomb sight, which was like a guessing device because there's like your movement, wind and all kinds of other factors. And of course the altitude. And the shape of the bomb, and so you had to put this all into and sort of make a calculation, which was all mechanical calculation, and then try to hit the thing. And it didn't really work out well. So even when they were seeing the target, they were like throwing the bombs all over the place. Yeah, and of course they were just supplying lots and lots of bombs to actually get the thing destroyed you wanted to destroy. And when they couldn't see things, they were like trying to navigate, and they had to throw their bombs by just more or less guessing where they are. They were off like by kilometers. So when they delivered the weapon to Nagasaki, they were off by several kilometers. Look this up in Wikipedia, how much of an error they had there. So, and then they were like ballistic missiles in the 1950s and 60s and even in the 70s. They were using inertial navigation, so they had to calculate over the whole flight where they are. And in the end, you could just hit something a kilometer, 2 kilometers or so off from the target, and this in 50% of the cases. That means like sometimes even further away. So your ability to hit something with precision with an intercontinental rocket was terrible. You were like targeting, for example, you target a bunker. Yeah? You target a bunker where the other guy is storing its rockets. Yeah? And you know where the bunker is because you also have like satellites, so you know the exact location. And the only problem is that you can't hit it. Yeah. Today you could just use different technology and you're much more precise. Yeah. But then at that time you couldn't really hit it. So you sent something there and then you had to send like 1, 2, 3 because like if there's just a 50% chance, you have to send like 5 or 10 rockets to that thing to actually hit near enough that it's actually getting destroyed. Yeah, that's the problem. If you are firing, you're trying to hit my nose, and to be somewhere really near to my nose, you actually have to fire 10 shots if your CEP is like this, because it's going there, and you need to have a statistical chance to actually hit somewhere here. Okay, so thank you for my nose. Don't hit me on your nose, please. But no, that's like the whole thing. And that was why we had nuclear weapons, because nuclear weapons are, when you have a normal bomb, you have like kilograms of explosives in there. Like a bomb, yeah, maybe the bomb is like 500 kilograms, 1,000 pounds. It's a very kind of standard bomb. There will be some 100 kilograms of explosives in there. The rest is metal, so that's like the thing. And that's like hundreds of kilograms. Now, when we talk about nuclear weapons, we are talking in TNT equivalent of kilotons. So that means thousands of tons of explosives. And then there's megatons. The largest nuclear weapons were in the tens of megatons. So the largest one was 57 megatons. That was 57 million tons of explosives. So it's so much more. It's such a big boom, these kind of weapons. If you are using the yield of like tens of megatons somewhere, you don't have to hit the thing exactly. You just have to hit it like, if you are off by 500 meters, the bunker is gone. That's why they had these really big and powerful weapons. The only problem is like they are destroying such a big area, and they are also causing so much fallout and radiological effects. So nowadays we have all these very precise weapons. So if you want to, for example, you want to destroy the capabilities of your enemy in a city and you have very precise weapons, you can target all the infrastructure, like you can target bridges, you can target electricity, water, telecommunication. You can just destroy all the things that your enemy really needs to run the whole operation without killing the whole population of that city. You can practically nowadays with drones and precision, with a large strike, you can take out a whole big city and take out all the infrastructure which allows people to live there. And you don't need such a big blast and destroy the whole city and kill all its inhabitants that we can do today. And as I said, if you don't hit something with precision, you need a terrible big explosion to actually destroy your target. But nowadays we have bunker busting bombs, which can actually, they are not only capable of hitting the target with precision, the fuses are able to actually count while they are going through several layers of concrete, and because usually bunkers are not like one, some of them are like one big block of concrete and you go through and then that's it. No, there are several bunkers where you can make the fuses count. Okay, I'm in, okay, layer 1, 2, 3, 4, 5. And then they know, now I'm on, I arrived at level 6. Here it is where I want to explode. Boom. That's what we can do today. And that's going to make a terrible difference. You don't need these nuclear weapons anymore. And then, of course, they had the idea of using nuclear weapons in a tactical sense. So that means, the strategic is you're sending over your nuclear weapons to another continent, to another country. But now you are fighting, you are like in a war, and you would be at your front line, and you are either sending a smaller nuclear weapon, smaller in the kiloton range, and destroying like the concentration of the enemy behind the front line, or you're using it really near the front line. But that's, as already said, it's really a bad idea because you're destroying the whole area and you're making it full of fallout, and it's like really senseless. And the more we actually have these very precise and small and cheap weapon systems which can be used en masse, they make a big difference. And that means all the developments we have in the Ukraine war is making nuclear weapons more and more obsolete. Because you can just produce thousands of small automatic self-targeting drones, program them, send them over. Let's strike hundreds or thousands of targets. Air defenses are not working against them, and they are cheap. Yeah, you can, if you mass produce something which is like only 1,000, 2,000, 3,000. Yeah, let's say they say the drones they use right now, they are in the €1,000 range. So you make 1,000 drones, that's 1 million. That's nothing. We are talking every year for nuclear weapons in the area of 100 billion. You know how much of drones and stuff you could produce? Yeah. So you can totally overwhelm your enemy, because even if they have a sophisticated air defense system, if you are sending over thousands of drones which strike with precision and thousands of missiles and so on, it's just you're overwhelming your enemy by en masse, and like the Hamas is trying to do with their rockets. But their rockets they are sending to Israel, they don't work because they have no precision. They're just sending over stuff which is like flying like artillery. They don't have the precision targeting capability. So you can have a sort of deterrence that you can show an enemy. Hey, if you are not behaving like I want you to behave, I can send you back to the Stone Age and destroy a whole city, that your people are really suffering and going out of the city, but they don't care anymore because I destroy your water, your electricity, your telecommunications, your bridges, your subways, your transport hubs, your rail systems, and so on. Yeah? I just destroy everything what you need to run your business, and then you're back to the Stone Age. Yeah? So, you destroy all the. If you for most people, if you just destroy the internet, then they will say, "Hey, we stop the war." So, and that means really the big difference in having lots and lots of weapons nowadays available in all kinds of systems, and produce them in very large quantities with very high precision, with respect to a weapon system which is designed to be just delivering a very big boom, and came out of an area where we couldn't really hit things with precision. And why we still have nuclear weapons? Because they are there. No? They are just left over. It's like the dinosaurs. We still have them, and that's why. Have you ever been in an organization and you ask, why are we doing this? And then we say, we have always done it like this. Yeah, that's the main reason why we still have nuclear weapons, because we still have them. It's always has been like this. Yeah, we still have them, and now it's really the right time to get rid of them, to make the world a safer place. And how will we do with this? Okay, go to zero-nukes.net, join, and then let's build a social media movement to get rid of this stuff. Thank you very much for watching. Follow the channel.